We've seen how to solve equations like this one here. We would subtract 4 from both sides in order to get 2x is equal to 16. We would then divide both sides by 2 to give us x is equal to 8. An inequality looks like one of these things down here, and we read them as follows. We would say 2x plus 4 is less than 20. So the expression 2x plus 4, when you put in the numerical value of x, the answer is going to be less than 20. 2x plus 4 is greater than 20. 2x plus 4 is less than or equal to 20. And lastly, 2x plus 4 is greater than or equal to 20. It's really important that we know what these signs mean, so if we just write that down, this is less than, so for example, 2 is less than 3. On the other hand, I can say 3 is greater than 2. I always think of the larger number pointing at the smaller number. So greater than. We could say 2 is less than or equal to 3, but generally we just use that with variables. We can say, for example, x is less than or equal to y. That's less or equal to, less than or equal to. And finally, we would have, if this was true, then y would be greater than or equal to x. That's just an example. It's not always true for x and y because they are variables, but it's just an example. So y is greater than, or equal to x. Here's an example. We want to solve the inequality and then indicate the solution on the number line. So with an equation, if you wanted to indicate your solution, you would just circle the solution. So if the answer was 3, you would just circle 3 and leave it at that. It's slightly different with an inequality, but first of all, let's solve the inequality. So we're going to solve it exactly the same way as we'd solve the equation 2x minus 3 is equal to 7. So if underneath the inequality, we can just write 2x minus 3 equals 7. And it's really important that you leave the 2x minus 3 on the left-hand side and the 7 on the right-hand side. Let's imagine solving this equation. I would first add 3 to both sides. So 2x would be equal to 10. I would then divide both sides by 2. So x would be 10 divided by 2, which is 5. But this is an inequality. So wherever we have an equal sign, we should change it to the same inequality sign, the greater than sign. So I can say that my answer would be that x is larger or greater than 5. So to represent this on a number line, because its x is greater than 5, I'm going to do an open circle on 5. Now, x is greater than this number. It's greater than 5. So that means it lies to the right of 5. So I'm just going to do a little arrow to the right of 5 to show me that x can be anything greater than 5. And that's how I'd indicate my solution on the number line. You could also just do a line here, but I don't think that really matters. What if we wanted to solve this inequality and then indicate our solution on the number line? Let's get a bit more space here. We do this. We do the work in the same way. We imagine that we have the equation 2x minus 5 is equal to 25. And I'm going to add 5 to both sides, so that would give me 2x equals 30, and then divide both sides by 2, which will give me x equals 15. But really, we have a less than or equal to sign. So these equal signs should be changed for less than or equal to. And that means that x is less than or equal to 15. To represent this on the number line, I'm going to circle 15, but it needs to be a shaded circle because we include the 15. So whenever we include the 15 or include the number because it's less than or equal to or greater than or equal to, we need to have a colored in circle. So I'm going to put a colored in circle on 15. and I'm going to draw my arrow to the left of 15 because x is less than or equal to 15. And that's how I'd represent my solution on the number line. Let's have a look at some GCSE style examples. So if I want to solve the inequality 5x minus 9 is less than 31, I would first add 9 to both sides. So we imagine that we have the equation 5x minus 9 is equal to 31. If I add 9 to both sides, we would have 5x equals 40. Dividing both sides by 5 would give us x equals 40 divided by 5, which is 8. But we really have a less than sign. So we have 5x minus 9 less than 31, 5x less than 40, x less than 8. We want to give the largest integer, and just remember that means whole number, which satisfies the inequality in A. So if we consider what this would be on a number line, so say we have 6, 7, 8, 9, 10, so on. X is less than 8, so I'd have an open circle on 8 and then an arrow to the left of it. So x cannot be 8 because it's less than it. So what's the first whole number that you'd run into if you would go left of 8? Well, that would be 7. So the largest integer which satisfies the inequality is 7. So the largest integer value that would work would be x equals 7. Let's have a look at 2a. So in 2a, we want to solve the inequality 4x minus 4 is less than 3. So I imagine that it's an equation, 4x minus 4 equals 3. I add 4 to both sides, so I get 4x equals 7. I would divide both sides by 4, so x would be 7 over 4. Now 7 over 4 is, if I change this to a mixed number, the same as 1 3/4, or 1.75. So really, we need to have a less than sign, so I can say x is less than 1 3/4. So on a number line, 0, 1, 2, 1 3/4 is about here. X needs to be less than 1 3/4, so our value is going to be to the left of that on the number line. If I'm going left of 1 3/4, the first integer that I'd run into would be 1. So that means the largest integer value which satisfies the inequality is 1, x equals 1. Finally, for 3a, we want to solve the inequality, or for question 3, solve the inequality 2x plus 8 is greater than 13. So what I'm going to do is subtract 8 from both sides. So 2x is greater than 13 take away 8, which is 5. So 2x is greater than 5. And I would then divide both sides by 2. X is greater than 5 over 2. So I can say x is greater than 2.5, or 2.5. So x is greater than 2.5. So again, if I consider a number line, so 2, 3, 4, and so on, 2.5 is exactly halfway between 2 and 3. X is greater than this, so it's an open circle, and we're looking to the right of 2.5. We want the smallest whole number which can satisfy the inequality. So if x is greater than 2.5, I'm going right of 2.5. The first whole number that I run into is 3. So the smallest integer which satisfies the inequality is x equals 3. Finally, let's look at forming inequalities. So in this question, Alice, Bob, and Charlie have collections of marbles. Alice has n marbles. Bob has 3 times as many marbles as Alice. Charlie has 11 marbles. Altogether, all 3 of them have over 50 marbles. We want to work out the fewest number of marbles that Alice could have. So just to keep track of this, let's do some workings. So I can say Alice has n marbles, so I'll say A colon n. Bob has 3 times as many marbles as Alice. So I can say Bob is going to have 3 times n, or 3n marbles. Charlie has 11 marbles. We're told that altogether they have over 50 marbles. So I need to take the number of marbles that each of them has and add them up. And that result will be greater than 50. So if I do n, that's Alice, plus 3n for Bob, plus 11, the result of this will be greater than, so I use a greater than sign, 50. Let's collect like terms on the left-hand side. 3n plus n is 4n, so I can say 4n plus 11 is greater than 50. I could subtract 11 from both sides, which will give me 4n is greater than 39. To get n on its own, I could divide both sides by 4. So n is greater than 39 divided by 4. So I can say n is greater than, so 39 divided by 4. 4 into 39 is going to go 9 times with remainder 5. Or better yet, not remainder 5, sorry, it'll go 5 times with remainder 3. 9 times with remainder 3, sorry. So n is greater than 9 3/4. So you could use a bus stop if you wanted to, by the way. So 39 divided by 4. 4 into 3 goes none, remainder 3. 4 into 39 goes 9 with remainder 3. 4 into 30 goes 7 with remainder 2. 4 into 20 goes 5, 9.75 if you wanted to. So we can say that n is greater than 9 3/4. If I consider a number line, 9 3/4 is here. N is greater than this, so it's going to be to the right. So I need to work out the fewest number of marbles that Alice has. So what is the smallest value that n could be? Well, if I'm going right of 9 3/4, the first whole number that I run into is 10. So I can say the smallest value that n could be is 10. So I can say the fewest number of marbles that Alice has. So fewest number of marbles Alice has equals 10. Here are some questions for you to try. Please pause the video now and have a go at them, and when you're ready for the answers, press play. Here are the answers. For the last question, we should have that the greatest possible integer value of n is 8, so the greatest number of sweets that Aaron could have would be 8.